Hello, I am Authentication, a PhD student at Lyris Laboratory in Lyon, France. I'm here to make a presentation on our work titled Diffusion-Based Authentication of Copy Detection Patterns, a multimodal framework with printer signature conditioning, which was funded by the French National Agency under the Trusted Project. Counterfeiting is a major global problem. One practical countermeasure is the use of copy detection patterns, which are binary patterns printed directly on product labels. They were once considered to be secure because copying introduces degradation that reveals fakes. However, modern generative methods can now reproduce them with minimal degradation. This raises our central question: how do we robustly authenticate CDPs against generative attacks? Three families of prior work exist. We have template-based methods that compare the printed CDP against its template, but fail on generative-based counterfeits that produce almost identical similarity scores. Printer-based methods learn printer signatures, but they break when the template is unknown. Finally, synthesis-based methods lack cross-printer generalization entirely. None of them handle all three factors jointly, and that's exactly the gap we address. We use a diffusion model for its ability to learn complex data distributions. We adopt the control nets, which adds structured conditioning for control generation. For example, in pose transfer, it takes an input image and a pose map and generates the same person in the new pose. Our first notable contribution is the adaptation of this image conditioned architecture beyond generation purposes. We achieve this by dropping the decoder block and replacing it with a non-trainable classification block that predicts the class of the printed CDP pair based on the detected printer signature learned during diffusion training. We select as a predicted class the class having the least error between the noise predicted by the model and the actual added noise in the forward diffusion process. Next, for the first time in CDP authentication, we support multi-printer authentication on the basis of our multi-class formulation. Then, we consider that printers inherently have identities based on the fact that they leave unique signatures on their printed outputs due to hardware and mechanical variations. And we propose to model these signatures for each printer using the reverse diffusion process learned during training. Finally, on the application side, we propose a novel framework that jointly uses the template, the printed CDP, and printer identity for improved, robust authentication. Subsequently, for authentication, we simply check whether the predicted printer matches the enrolled authentic printer. If it matches, the product is authentic. Any mismatch, even another legitimate printer, is considered counterfeit. Since counterfeits are a product of an initial authentic CDP, we assume that this authentic class label for all samples is known as at test time. We evaluate on the Indigo 1x1 based datasets, which includes authentic CDPs from two industrial printers, the Indigo 5500 and 7600, along with DNN-generated counterfeits. To enable multi-printer evaluation, we reformulate this dataset as a 6-class problem, where each printer template pair defines a class. We report the balanced error rates and train with a 70-10-20 split with knowledge of fake types. Now, I'll show how our diffusion-based authentication performs in this setting. For results, our method consistently achieves lower balanced error rates than prior CDP baselines. It remains robust against DNN-based counterfeits, where similarity-based methods degrade. This single unified model supports multiple printers, and we achieve better control over false acceptances without sacrificing authentic detection. To evaluate our method's generalization to unknown counterfeit types, we train on authentic and same printer counterfeits only. At test time, we evaluate on cross-printer counterfeits that were never seen during training. For this, we achieve zero false accepts, meaning perfect rejection of unseen counterfeits. In summary, we propose a unified CDP authentication framework that integrates the template, the printed CDP, and the printer identity. We extend control nets to classification, which enables multi-printer support and achieves zero false accepts on unseen counterfeits. Although we generalize to unseen counterfeits, future work should explore removing counterfeit data from the training entirely, introducing larger printer variability, and evaluating robustness to diverse scanning pipelines. The paper and the code can be accessed by scanning the provided QR code. We have our references on this slide, and thank you very much for your time.